Hello, everybody. How are you doing?
Hello, thank you, Professor Asi.
Welcome to the class, Abu Bakr. How are you doing?
Yeah, I'm fine.
Is that how I should pronounce your name, or
Yeah,
you go with Abu Bakr?
Yeah, you can say Abu. That's much easier.
Abu. Okay.
Yeah.
Okay. Oh, I see you sat outside. How's the weather?
Yeah, nice.
Great.
Yeah,
Hello, Professor. How are you?
Hello, Kavish. I'm doing great. How are you doing?
I'm also doing great.
How's the grader job?
Going good so far. Had some problem in the start, but it's good so far.
Okay, great. I hope it's not very tiring for you.
No. It's perfectly all right.
Okay. Okay, we are waiting for a couple of more minutes, and then we do what we normally do. We review the class, and then we talk about the assignments and if you have any questions or anything. Hello, Anish, how are you doing?
Hello, Professor. I'm good. How are you?
Hi, Professor.
Hello, how are you?
I'm doing good. How are you?
I'm doing great. How's everything?
Going good.
Good. How's life?
I can say I'm just shunting because I took 4 courses. So just switching around is.
What are the other courses you have?
So I have taken one cost estimation, then another one is agile, and the fourth one is web programming.
Yeah, all of them are very busy, have a lot of homework and stuff.
Yeah. But having good time to learn all these things because I was curious to know about all these aspects. So it's nice.
That's great. Good luck. Hello, Farah.
Professor,
How are you doing?
I'm good. How are you?
Oh, I'm doing great, guys. I visited my parents. That's why last week Fatih was here instead of me. I was flying back, and I cannot complain. Life is not any better. It's perfect.
Great.
Hello, Gabriela. Also, we have Nila and Kyle. Means we have 2 people here.
No, that's me, Professor. This is email. Like maybe my kids would have used this. Sorry.
No, that's totally okay. I thought maybe 2 students are like roommate or something.
No, that's my kids. I need to change the name. They go for some of the Zoom classes through the computer, so they put their name on it.
Yeah, I totally understand that. My parents sometimes do that with my account. I mean, that was my mistake. I taught them how to use Zoom, and now they just using my account. I mean, it depends. Like, I have this story around 7 years ago. I just started the PhD, and then my dad had open heart surgery. Like, he had 2 surgeries in 2 years in a round, and he couldn't do anything, right? And then when you stay at home doing nothing, you start poking other people. So one way that I found that maybe he can be like engaged with not a lot of stress was when I was writing papers. He was my co-author, and my dad doesn't know English, so all he could do was just commenting on the graphs that we had, right? And of course, see, look at the situation like this. He doesn't know English, but he knows French, and he's a lawyer. We are doing software engineering. So what a comment can come from a lawyer who doesn't know English on any graph? Either the color or the type of line that you're using or the readability, right? And then at the end of the day, his name never would go to the paper because he wasn't the author, but he was happy that his last name is there. And for almost, I guess, 3 papers, he wouldn't hang out with anyone on the deadlines or anything because he had a paper to submit, meaning asking why this part of the graph is red, not blue. Now they're doing the same thing with the Zoom. He's happy that the last name is there so everyone knows that people are talking to him, but my mom doesn't have anything to do. Yeah, but they're happy. I'm happy. That's great. They have fun. They feel involved. That's all matters. Okay, let's start, guys. So how many of you already watched the video for the previous class that I practically?
I did. Just like half of it.
Just half of it?
I finished 1 hour.
Oh, I'm almost 1 hour as well.
Sorry, I didn't get to see it.
I have a question. If for some reason on Thursday we cannot review, nobody's going to read the material or stuff. It's not that I'm going to stop. It's just out of curiosity.
I mean, I just had a really busy week, so I had to kind of postpone it because it didn't have an submit deadline thing. I had things that piled up, but I tried to watch it.
Okay.
Yeah, that kind of echoes my thought too, Professor. Usually what I do is I watch it on a Friday and then go for homework right from there.
Okay, great. No, as long as I know that you guys are watching, or maybe not watching, and just read the slides and the papers and stuff, it's good. I just want to make sure that you actually grab whatever it's needed for future. Okay, this week the title was about requirement and architecture engineering. From the fundamental of software engineering, what is the architecture, guys? Which part we call architecture and why we need the requirement? Yes, Gabriel.
Architecture, at least the way I remember it, is the high kind of high concept aspect of the design. It's not talking about like specific functions like you would with the code, but more like, I think, overall functionalities.
Mm-hmm. And what was the requirement?
Requirements are more specific, kind of like it needs to do this. Like as a user, I need it to do X, Y, and Z. Like for a bank account, I need it to be able to deposit money would be like a requirement.
Yeah.
That's yeah.
So generally each function is going under one requirement, right? So that can be a functional requirement or non-functional requirement, meaning functional would be the integrity, non-functional would be the behavior, right? So in testing, we are following the same concepts as well. So we have some questions that we need to ask. But every time till now, we learn that whenever we start testing, we first want to make sure that what we want to touch, exactly know which part of the system I want to test, and the test is going to answer what need, right? Then we can look at the different requirements for that we need to test. So it's exactly like agile methodology. Whenever we start testing, we do everything parallel with all the previous phases. The development, the design, the requirement, so we can improve that while we are working on it. Therefore, we need to review that. We need to make sure that the tests are traceable. So we define different metrics for that. Then we go through different checklists. We have the prototype. Then we go through the review board, and we do the capability maturity model. What do we mean by each of them? The questions that we need to answer was like any other type of the requirement and the testing that we are looking. We want to have the minimum fault. We want to have the highest quality. We want to make sure that the system does what it's supposed to do and the behavior is right? So minimum fault, how to project a reduce failure, and how I'm going to improve the quality. For doing that, we start with the requirement. Remember, first week homework, we worked on a triangle requirement, right? So we wanted to create a program that we give it any three numbers as three sides of the triangle, and it gives us the type of the triangle and if that's correct or not, right? So the answers that can be asked, the questions that we can ask that go with the previous slide is, one, are these requirements good? Does it cover the entire purpose of the program? Two, are they complete? If I have these requirements, I can return exact thing that I wanted. And three, any important missing requirements that I didn't touch. So we wanted to go through that to make sure that all the three links that we have create a triangle and that what type of triangle it is, right? So one is, what if the parameters are invalid? What should I do when I want to test this? I want to make sure that all the parameters are positive, right? What are the return value to make sure that it's a triangle? And also the valid range. Valid range means that I do not have a zero. There is this triangle formula that the sum of each two is greater than the third one. And if it's a right triangle, that would be the square root of each of them, right? So when I look at them, I would understand that the requirements that I had was ambiguous. It wouldn't cover all the requirements that I needed to do, all the functionality. Then we have the boundary conditions that each side must be positive, and the valid triangle formula that it was not given to us by the question. So we need to write it down. For the invalid, when we wanted to test, we need to analyze that. We need to make sure that it doesn't return none. It returns a specific value and it through the expectation, right? Also the valid, I want to have a real value as an input, and we want to see the accuracy, how much precision is required, how accurate we want to go for that. So that was a general example of different requirements that we want to look at. For doing that, we need to know the goal. The goal is, what are the requirements that help me create a new system? The system does the job based on that, right? We already know that from the fundamental of software engineering. Now, when we look at the testing, we need to follow the same steps. So we have 3 different requirements. We have a traditional requirement, is plan-driven, coming from waterfall. Then we have use case requirements that based on different usage, we are doing that. That can be a combination of agile and the waterfall. And then we have user stories that mostly uses in agile. And if you remember, in agile, we do not do requirement as 1, 2, 3. We mostly use the user story that we get from real life experiences that our customer are giving us. So the first one, plan-driven, we said that is going through the traditional waterfall. In waterfall, the limitation that we had was each phase only covers that phase. If we find out that something needs to be updated, we cannot go back to the previous phase and update that. We need to wait for the next version, right? So here, if the requirements is not invested enough and it's not documented enough, we will have a lot of problems, right? So we need to describe all the features based on our understanding and the vision of the customer at the moment. And we need to have a test based on that. So every time that I'm writing a requirement, I must write a test case scenario for it before I start design or I start developing. I need to have a vision in my mind that how I'm going to test this specific requirement. And at the end of the day, when the requirement phase is finished, we are going through the business requirement document. We submit everything as an intensive documentation, and we have a meeting to review everything. In the use cases, we describe the entire scenario for different actors and how they're going to work with that. All the possible scenarios that we can do. For example, I want to play a song. I'm the user and I have this my laptop as the system. How I'm going to play the song, how I'm going to explore different music, the profile that I can create. I can use my laptop for playing song from the memory that I save, or it can be a tool for me to, for example, go to Spotify and start playing the music that I want from there. Again, when I have a use case, each specific scenario that I'm writing down parallelly at the same time, I need to think about the test cases. How I'm going to test this specific scenario to make sure that it's working well. And the user stories, remember, it was coming from the real experience and stories that customers are telling me. So we have the priority of each user story based on the customer decision, what part of the system or what experience they want to have first. So the entire point till page 12 is, no matter what type of development process we are choosing, as soon as we get the pen to write down the requirement, we must think about how we are going to test this requirement. So parallel with each requirement, user story or user case that we are writing, we need to write a test cases for them before we go to design or even development. For user stories, when we are designing the test as well, we have following the same template that we follow in the Agile for the requirement. So we have a title. We need to make sure that what is the title of our story. Then we have the acceptance test, the story that how we are going to test this story or this scenario. We need to agree on it, and then we write it down. Then we put the priority of the test. Normally for each scenario, we have more than one test case, right? Because we have different actors or different functionality maybe in each user story. So we have this very close contact and meeting with the customers to rank the level of importance of different user story that we want to use. Also, we have different points for each test story that we are writing that helps us to implement different relative units, which directly comes from the level of importance. And then at the end, we describe the story in one or two sentences to make sure that we know the relations, which can trace back each test story to the user story. Imagine one example that we have. We created a system to go to Mars, and it started sending data about the distances in Mars. Go back to Earth. What can go wrong? This is actually a true story. In NASA, everyone was designing, or the engineers who were designing were not American. Therefore, they design everything metrics, a measure that is used everywhere but in US. So the information that this system was sending back to the Earth was metric. However, here, that's not the measurement that we are using. Therefore, the data wasn't used. And for the first couple of days, nothing would go right. Everything was mismatching. We have two different test approaches. It's exactly like the architecture. Either we have a static review or we have the dynamic review. For the static review, the goal is understanding the functionality of the system. We are testing each function, each lines of the code. Practically, it goes to the integrity. For the dynamic, we want to make sure the behavior performance of the system. So we look at the non-functional requirements mostly, right? Therefore, we have different tools that we can use. For static review, we are looking at the inspection. What is the specific job? We can walk through each requirements. We can read them one by one and see what's going on. Then we have a peer review. When the requirement documentation is done, we can go through different meetings and ask different colleagues to review that. Or we have a checklist. We ourselves review that and we make sure that we follow every step. In the dynamic, the entire idea is look at the non-functional requirements, right? So we want to see the behavior of the system, the performance of the system. So we can look at the prototype. What was a prototype, if you remember? A prototype is the smallest or simplest level of a system. It's not complex yet to have a lot of failure, but it can sell the entire idea of what the system is going to do. Then we have different models that we can look at. We are following the same models that we had in requirement engineering, and we look at the verification and validation in the system. What is the difference between verification and validation, guys?
So the one is, are we building the right system? Another one is the system what we built is correct.
Exactly. For the verification, we make sure that we build the system we were supposed to do. For the validation, we make sure that the system behaves the way we expect or the customer expect to see. Practically, verification is going under functional. Validation goes under non-functional, if that's easier to remember. So let's start with the static. The first step was we talked about the inspection. So how we are going to do that? We are reviewing the system, all the test scenarios and the requirements. One by one, we make sure that everything is correct. And then we have different teams that are assigned to different tasks in the inspection. We make sure that everyone reviews the requirements and they participate in the process. It's not just one person who's doing that. Then we review all the data and we determine that each section of the requirements doesn't have any error, if there is any change needed to be done, we do that. This mostly happens in traditional waterfall system, when we actually write down the requirements as a big documentation. So we can have different scenarios for that. The most famous examples of some success scenarios was when we did, different companies like Microsoft, IBM, AT&T started going through the requirements. That helped them to in somewhere like AT&T, they had 90% improvement in finding the errors, because before they start developing, they find that the problem. Somewhere like Athena found 82% of the error, and then they could reduce the development resources to 25% because they didn't need to redo the job. So that directly impacts on the financial aspect as well. When you decrease in the defect, you need less manpower to start working for you, and then that would be faster. So you have shorter release time to the market. For formal inspection, normally we go to the bigger projects when we have multiple engineers from different phases. We need to go through the entire development life cycle. We work together, and then what we want to look at, we want to look at any work product. What is the plan? What is the documentation? All the requirement, design, architecture, code, any artifact that we have. And we do this when we want to claim that we have a baseline ready, that we can start developing everything on top of that. So before we have the baseline, remember we said everything is informal, even the inspection. As soon as we want to introduce a baseline, then suddenly everything becomes formal, because we needed to document everything very carefully for future purposes. The informal inspection can go under like pair programming, when we do that in agile methodology, or side-by-side programming. We work on our project, but we talk loudly to each other and we can ask for help. This helps us to review each other's work. This helps us to put comment, understand new ideas, but nobody there is assigned to review my requirement or my documentation. It helps to identify defect. We find what if something is wrong, we reviewing it once after we write. If we find a missing information, there are some common errors that always happens. This helps us to have less of them. Then there are standard violations in different ethics, different policies. Then we can review them and we can understand them. If there is ambiguity because someone else is reviewing my requirement, if they do not understand that, they can come back to me and we can rewrite it in a more clear way. Then inconsistency, there is inconsistency there, and the design flaw. So inspection help us to reduce the defects with having 7 different usage or benefits. And of course, in testing, we always do stuff based on the planning. When we do planning, we must have a strategy. What is the strategy that we want to have? We want to look at the false positive. We want to identify anything that might be or might become a problem. So the fact that I only find stuff that was wrong is not enough. Even if there is a risk that something is not going to be correct, I want to find that as well. Another one in another method was walking through. What walking through means, every time that I want to do a test scenario, I walk through the scenario one by one, read it step by step by myself and try to understand. So there are different goals for that. When I'm looking at the inspection, till here we learned that the goal of the inspection is reviewing for improvement. What does that mean? The improvement comes with the lower number of defects. So I want to find what is wrong, find the defect. When I'm doing the walking through, because I'm doing my own work, like I review my own work. So I want to improve the product. I don't care how many defects I find. I care about how can I do it better or write it better, that I can have a better product. So the activities, of course, in both of them, I'm going to find defects. When I'm doing the inspection and I find a defect, I want to explain and learn through the defects and try to make sure that I have less defects. But when in walking through, I find a defect, sure, I want to have less defects, but it's not with correcting that. It's with what are the other alternatives that I can take based on the discussions and learning experiences. Walking through is very informal. We can talk about why we disagree or why we agree. Inspections happen when we want to have a baseline. So it is formal. The quality for the inspection can be all keep repeatable. Every time that we want to change something in the baseline, for example, we need to repeat the inspection. For the walking through, it's very, it's not constant. It's based on different personalities of the people in the team that they are going through the discussions about the improvement of the product. How long does it take? When we are doing the inspection, we have extensive preparation because we need to have extensive documentation and we want to optimize the process efficiency. When I'm doing the walking through, it is informal and it belongs to the ad hoc preparation. So it doesn't really need to have very long time. We can do that over like lunch talk and just discuss about alternative ways that we can take it. It's mostly a result of brainstorming. But what should we look at? We need to review the most critical components. We need to look at the most sections. What do we, the most used sections, the most costly defect if something happens, my entire system is crashing and I'm losing the market, for example. What are the error prone? Most recently written change. Why do we need to look at the most recently written or change part?
Because usually that's where you'll find a lot of bugs, especially if they just popped up pretty soon after like a recent commit.
Yes, but why that happens? Remember from the first session, we say that we start doing the test as soon as possible and we keep repeating ourselves, right? So by the time that the recent 10 lines, for example, are out, the previous lines had at least once reviewed by a test engineer and we try to find the errors and faults. The part that just added never has been seen. That's why we always started with them, exactly like what Gabriela said. There are chances are that the higher level of the errors are coming from the newer part. On the other hand, we always focus on the newer part first, based on the same thing that I just explained. The previous part were reviewed at least once, the newer part never reviewed. And also we know that we do not have time to test the entire system, every possible combination in the system. That's why we are doing the decision table scenarios, for example, so we can reduce the combination. So we always start with the highly critical changes to make sure that there is no important fault left there. The process is we start doing the preparation, we review all the artifacts that we have, we start reading that, then we do the inspection, we find all the errors that we could find, we fix whatever that we could fix, and then we write a report, we submit the report, and then we start the work. The reworking means that we are resolving the issues that we could find during the inspection. Also, while we are resolving the issues, if there is a new fault that we find, for some reason during the inspection, we overseen that, we need to add it back to the documentation and report that we have. There are some reading techniques that we need to do. Remember in waterfall, when we are doing the inspection, since we haven't started the development yet, it's purely text-based reading, right? So we need to look at the defect detection is more than individual than a group activity. We do not have anyone to go and talk to them unless we want to go back to the engineer who wrote the requirements because we didn't understand what they write. There is no design really available yet, so we cannot argue on how does it work or how it is not working. The result depends on the inspection participants themselves. It comes from how we understand the situation and how we like. It's very personal taste, we can say. So maybe if I review a requirement document, I find 5 faults, and I don't know if Jose reviewed that, he find 15, because it's very much based on personal taste. There are people who has technical expertise to do inspections. So we can use them as an inspector to help us to detect the defects. And that helps to increase the effectiveness of the requirement that we have for further purposes when we start the development. Also, based on what we want to do, we can follow different reading techniques. We can do ad hoc, go through line by line, whatever we have in the requirement. We can do checklist. We have a list of what it should be there and what is not, so we can compare. We can do the perspective-based reading based on what we assume different roles are going to do. We can create a scenario in our mind and review the situation. We can do the scenario-based on a real-world story. We can follow the requirements and try to see if these requirements fulfill what is input-output behavior of that real-life story that I expect to see. Before I go any further, any questions?
Yes, please. Can you please move back to the slide?
Slide 27?
Yeah. Can you explain a little bit ad hoc, please?
Oh, ad hoc is in development site. Instead of we say waterfall or traditional, we call them ad hoc.
Thanks, Professor.
Sure. Any other questions still here, guys? Okay. On the other hand, when we are finding different defects, we can categorize them based on the level of importance. So I have an ID for different defects that I find. This ID can be associated to the requirement ID. Then I have the level of severity that how important it was. It was high, medium, low, or I have a question, I couldn't understand what's going on. The location would be the requirement, exact line and page that in the documentation I find. And the description would be a small, maybe scenario or the questions that pops up. For example, if the defect is high because I had a test case scenario in my mind and this specific requirement does not pass the test case. So I need to describe the test case and why it failed. Then the report is going to submit it to a meeting. So we have different people in a meeting and with different roles. We have a moderator. Moderator normally runs the meeting and set the pace of the meeting, how fast or slow it should go. Then we have a recorder, someone who's documenting everything that is going on, working on the issues and maintain the defect log to make sure that pass them to the engineers to update. Then we have a reviewers. They are identify the defects. That was the inspector who were working on the documents. We have the others. They observe what's going on in the meeting and they always remain silent. What they do is they take notes to, after the meeting, comments, if we are out of scope, come and help us. And we have a wrap-up. That's a final comments that everyone is putting. Normally, the recorder write that down. Then we have action items that who's going to do what for the next meeting. We have a distribute minutes after the meeting. We will have an email or document going out based on all the tasks assigned to different people or the discussion. What was the solution? What was the result? And that minutes is going to be submitted as a distributed report to the documentation. Of course, after some time, we need to have a follow-up to make sure that people do what they were supposed to do. Everyone performed the task and all the defect that we were finding was solved in the best way possible. And why are inspections effective? They help us to review all the documentation and we make sure that we have a good preparation for the intensive documentation. Then we have a peer pressure because we find out a lot of defects, and carefully we try to correct them. So in future we have less pressure. Then we have a formal process. We need to document everything, all the reviews to go through. So we know what we changed that help us in traceability. And then we focus on the highest payoff. What was the highest level of importance that helped us in the future? The next one was checklist. In checklist, exactly like any other checklist that we do, for example, when we plan for studying during a day, there is a list of what is supposed to be in a document, what not supposed to be there, and what is the flow that we want to follow. And then we need to check to make sure that all the parts of the projects and in the requirement phase are there. There's an example. Boeing in 1930 developed an airplane, B-17. It was really fast. It was great. Everyone were very impressed, but it didn't actually work in the very first test. However, later on in World War II, it helped a lot. What was wrong? The pilot didn't follow the checklist. I mean, there was no checklist, so the pilot forgot one step. So he couldn't land. So we sometimes really need to have a checklist because it's too much to remember, and that help us to find out the root of the problems. We can analyze when we follow each steps that is supposed to be followed. And we have a very simple requirement checklist as a template that we have all the specific requirements that we need or steps that we need to be taken in the requirement. And then we just check if it is there or not. If it's there, great. If it's not, why not? Or what is the problem it will cause, or how we can add that? Or if it is there, even at some point, how we can improve that, how we can update that, the specific part that it was there. So when we are writing the checklist, we need to make sure that we prioritize all the requirements that we have in the checklist based on what we need to do. The trade-off between the requirements are clear. Then we need to make sure that they are clear. We do not want to have any unambiguous requirements there. Then we need to make sure that they are verifiable. I can verify it when I'm developing it. It's not just something that I thought it's needed, but I cannot design or I cannot develop. It needs to be consistent. Requirement A, B, C, and D needs to follow the framework and be consistent. I cannot, the example that we had with NASA, I cannot create some part of the system with metrics and the other one with miles. And then it needs to be traceable. Every time that I make something, every time that I change something, we update a part, we need to make sure that we can trace it back to the origin and roots of the requirements. We need to understand why we did the change. Remember, we had the change board that we needed to get the approval after baseline. This traceability goes under that part. If I'm going to check the code review as a checklist, we need to look at some comments that are there. We need to make sure the style is correct. We look at the bad smells. We look at the security threat. And normally we can, if we can do more than 80% coverage, we say that our code is good. Otherwise, it's not good. So any questions still here? Okay. What was the, if you remember in the very first class, we said that we have three factors for testing. That was very important. What was that? As a test engineer, we want to make sure that our system has the integrity, it is repeatable, and it's traceable. So the same thing goes for all parts of testing, right? Therefore, we need to look at the requirement traceability as well. We have a forward traceability and we have a backward traceability. Every time that I start updating the system, the requirement, I need to make sure that I can trace it back. On the other hand, at any point that I look at the system, I need to have the visibility to make sure I understand what is the next step that change and what is the previous step. The next step goes for forward traceability. The previous step goes for the backward traceability. We have some benefits of the traceability in the system. It ensures that every requirement is implemented and tested. It measures the completeness of the test coverage. It measures impact of the change request. Also, it can help me to go back to the root of the requirement, and I can understand different problems and faults if it's there. And at the end, it's the best way for audits and inspection of the requirements when we are writing different test scenarios. So from the traceability, I write a test scenario. I need to make sure that from the test, I can always trace back to the requirement, to the design, and to the code. However, when I'm not even in the test, I'm doing the design, I need to be able to trace it back to the requirement that I read from and to the development part that I'm going to have access to. So when a system is done, from any point of the system that I stand, I need to be able to have a clear map of what was behind me and what is ahead of me. And this is a simple example of a traceability metric. For example, for the business rule, for the product requirement R00120, I have different updates, and each update should be added based on the unit code, unit under the test case, system under the test case, user manual. So I can be able to trace every step back, and I understand, for example, after UTS 41033, I can go and check as SD 120.022. Or when I'm looking at SD 120.021, I know that the unit code that I need to go and check would be the read card type, for example. What are the benefits? So the benefits is make sure that we have seen as high as 42-to-1 benefits to cost. So the traceability makes it faster, makes it cheaper, make sure that the quality is higher, so I'm going to the market sooner. It was said that you can expect that the development cycle improve by 50%. So instead of having a year in production, you're only having 6 months. Also, we can use the prototype as a testing. Remember, we said that the prototype is a simplified model of a system. We can use that to show the customer if what is our understanding and what the system is going to look, what the system is going to do, to make sure that our understanding of the system and their vision of the system they want is actually matching. Therefore, we can use that for different testing. It can help us to create different experience that may be very difficult or time consuming when we are waiting for the entire system. So we can do that in a very non-expensive way. Also, if it's hard to get right, we can do a lot of try and error. So we can have many iterations. But if I want to actually create the entire system, I need to hire multiple engineers and put a lot of manpower hour to work on that. It allows us to create, test, and improve very cheap without big investments. So it actually matters a lot to make sure that we always do on the prototype. What can we prototype? We can prototype any part of the system. And we do not need to always code for it. We can use as simple as the PowerPoint to create a vision and view of the system. And we can show different test scenarios or use cases to test the prototype and going through the scenario with our customers one by one. We have two different types of prototypes. One is the rapid throwaway prototype. We create something very fast just to make sure that our understanding of the system and requirements matching with this customer's vision and need of the system. Normally, in this case, we do not touch the prototype after we confirm we are on the right track, and that's it. We go create our system. The other one is evolutionary prototype. This one normally starts with a limited functionality. So the first one is as simple as some graphics, some, I don't know, even pen and paper. The second one, evolutionary prototype, starts actually with the coding. So we are going to have limited functionality of the system, and every time that we want to deliver a new version, we update that prototype. So by passing time, the prototype would be better and better and better, and eventually it will be our final system that we have. We can use that for testing the usability, clarity of the requirement, clarity of the design, and the test. So the clarity of the design and the requirement can go easily with the rapid prototype. But when we are going for the design and test cases, still I can use the rapid prototype. However, evolutionary prototype is better because we can actually go through different case scenario with the customer and see how it works. They can have a feeling of the system. And of course, there are advantages and disadvantages. The advantages are it makes sure that the customer are involved. They have a better understanding of the system. They can explore many alternatives of different scenarios and pick the one that they want or they feel it's easier for them. And we can easily identify missing or unneeded features that we didn't see. The disadvantages would be it has the risk of over-reliance on the prototype. Maybe it doesn't have insufficient requirement analysis, but because we didn't have the real data, we promise something that in reality we cannot do. Customer may become confused because they may think that the prototype is a final system. And when you, there is one reality, the prototype is always more beautiful than real world. So when you show the very perfect, beautiful prototype to a customer, they may think that the system is going to be as nice as this one, but in the reality may not happen. Also, it may lead to insufficient solutions. The last one was validation and verification. So remember that the validation was the system does what it's supposed to do. Verification is it delivers and behave as what customer expected to see. The basic architecture review for quality of the construction, VMV, was developed in Bell Labs for big software technology centers that they had. So for doing that, we want to make sure that we take the problem early. So we need to look at we need to use as different experts to help us and review the system that is similar to the systems they already saw. We improve the component and product management with the help of the experts that are going through that. We try to identify the gap and we try to fix it as soon as possible, very rapidly. That helps to promote the learning across the project because everyone is involved and we try to learn from each other. We keep all the experts engaged. They are not good only for management or leading. They actually are hands-on and doing stuff in the project. And we spread the knowledge of proven practices. When we do something together, we move to another project and we try to help each other learn and teach each other about, we try to teach each other about different knowledge that we gain. The principles we need to follow is, first, we need to clearly define the problem statement that we have. Then we need to understand the system architects and all the phases. Then we do the independent expert conduct review, meaning that the designer of the system is not going to review the system. Someone who never touched this system but worked on the similar systems are going to review the system. The review are open process, so everyone knows exactly what's happening at every stage. It's a white box. And we get the reviewers for, we reviews the projects for the benefits that it actually gaining for us. So what are the stages? We look at the problem statement. What is the problem? We go through the architecture. We try to find the problem and solve the problem. Then we review the process to make sure that it's working. If it's not, we again need to go back to architecture and make sure that we improve the problem that it was there. And then again, we do the review process. When we look at the review process in the architecture, we try to provide solution for a problem that the client pointed out. That means we have some constraint in the design. We have limitations based on client expectation. So any solution that I provide is one solution, but I always search for a better solution. Therefore, we are always going for some multi-layer architecture. We are not just stop with one. Remember again from the fundamental of software engineering, when we talk about user story, each user story can be one aspect. When I'm looking at UML is one aspect of the story. We need to have multiple stories, right? The same thing goes from the architecture. Each architecture is only one aspect. I need to have multiple aspects, meaning multiple architecture, to have the better solution. So I can cover the problem from different angles. The architecture is the combination, or it's the overlapping part of the management that looks at the profit, the schedule, standards, cost, design, that needs different view of the system and how we are going to marry them together, and the technology, different methods, different material, tools, and techniques that we create. Therefore, we need to make sure that we have a clear problem so we can provide a clear related architecture. The problem statement needs to be seen from a functional view, from the environment, how it's going to fit, from the economy, the life cycle and cost, from the release time, how the market is going to be impacted, and from the operation of how it's going to operate in the environment. So when I'm talking about the clear define, means that when I state a problem, I need to answer, or I need to look at all different parts and phases of a production, then I write it. When someone reads the statement, needs to have answer to all these different 5 steps. So we call that it's a focus on the ARB. What is the ARB problem? It should be short. It looks at the major constraints. It is client-centric. We need to talk to our customer very, very frequently. It should cover all the functionalities, form, economy, and time, and operations. How we are going to have a solution for all of this stuff. And it's high-level features. It's not just a requirement. It's coming from a very high-level summarization of the system. And kind of, you can look at it as a malperformance of the system when we want to look at a problem statement. So when we go to a review board to make sure that we find a solution for the problem, we have project members, project management, the review team. They are external experts that they didn't work on this project. We have the ARB chair. We have the review client. So we define the process, we compare it to the architecture, we identify the gaps, we try to find the solution and we resolve it. Then we need to go back and again, we review to make sure that everything is correct. And how well do organizations do these steps? Practically not very well. So we have a capability maturity model. The definition is it's a methodology to measure, develop, and refine software development process. That has 5 different steps. The very first level, maturity level, is the initial. It's before the baseline. It's very informal. We just get together and try to find a problem. Then we have maturity level 2 when we have a manager. We need to have, we are in the project level and we have a project manager that plan, perform, and measure the situation. Then in the maturity level 3, we have a definition of the problem. So we are not waiting for our team to go and find the problem. We proactively review all the requirements and we try to find the problem. We try to have a clear definition of the problem. Level 4, we have quantitatively managed, meaning that we have an organization that has enough history that we can use that as data-driven. We have similar projects that they can use as Oracle, so we can look at their data and we can manage the problem. We can formulate the problem easier, practically, based on the data. And the final one is the optimization. Here, not only we have the data, but also we want to focus on the continuous improvement. So our goal is not just finding the faults and problems, but improving the system in the best way possible. For having these 5 different levels of CMM, we can look at key components of the software development organization. We have software testing, we have quality assurance, we have inspections, we have architecture board, review board, we have checklist, and we have peer review. Based on different level of the projects that we are working, how big the company is, and the different process methods that we are using, we need to look at different steps. However, in most of the projects, we have at least 4 out of these 6 steps involved. Also, we need to have well-defined, documented, that is repeatable, is measurable, and constantly look at the improvement of the process. Any questions, guys? I mean, we have the extended video that I uploaded there. I guess the students asked questions as well. But today was the review. And in the review, is there any part that you need to discuss on?
No, I feel like it was all pretty straightforward.
Okay, great. So now let's go. If you have classes, I'm sorry, goodbye. But if you do not, do you have any problem or anything about the homework? I noticed that a couple of the grades are out, and so actually most of our friends had problem with the decision table. Is there any part that I can help or anything that you want to discuss about?
I think I'm good, Professor. I mean, I got the feedback, so it's cool. Thank you.
Okay, great. For this week homework, if you already started, is there anyone who has any questions? If not, sorry. If not, then you know how to find me. You need to discuss, please email me. I will make sure that I will put some time for you. Maybe during the day I'm in meeting or something, I do not respond. I will make sure that I will respond as soon as I'm done with my day job. And don't think that because it's late or something, I will not respond or I will not put the time. You need to talk, please talk. Do not confuse yourself with overthinking on how to do the homework. Just 5 minutes Zoom can do long way and make it easier.
We'll keep in mind. Thank you, Professor.
Okay, guys, have a great evening and see you next week.
Thank you, Professor. Thank you. Thanks.
Bye.
Bye.
Good night.
Bye,
Professor.
Good night.
Yeah, Professor.
Yes.
Okay. So I need to submit social media by 10 or I could submit.
Yes,
data.
Kunal, wait, please. Abu Bakr, Kunal, you two, wait, please. You two have the same situation. Even Kunal is not officially in the class yet, you are. So let's do this. We will wait till Saturday because Kunal received a response from IT that he will be added to the class by end of this week.
Okay.
Then we are in week 4. I will manage to make sure that from next week, you will have 4 weeks to each week respond to 1 week that you are behind. Right. But then one thing is, unfortunately, I cannot do that for all the homeworks, meaning from next week, week 5, next Sunday, you need to submit week 1 and week 5, whatever that is included, up to 4 weeks. Is that working for you both?
Yeah, Professor. Yeah, no issues on my side.
How about you, Abu Bakr?
How about if we start submitting from those coming homework, because you have to make sure to read those things to understand them well and submit them.
Okay,
How
so
about that?
okay, so that works with Kunal. Kunal, for you, we are going that way. For you, we can start, we can give you like another 2 week. You submit week 1 and 2. Then you know how the situation is working, because at some point we need to be a little bit faster. I cannot see, it is already a month, and
Yeah.
I cannot give you 4 weeks after the finals. We need to make sure that you submit everything before December 10th.
Yeah,
Okay.
Professor, just I'm like waiting for the IT department. If they
No.
like mail me in today itself, it's a good thing for me. But like hope for the best. That's the best thing I can.
Yeah, no, don't worry about the deadlines. The only thing is, again, we need to make sure that you both submit everything by December 10th. So
Yeah.
the weeks that you are missing, I will open it later for you. In case that, like, you were my student last semester, Kunal, you know how to submit and how to do the work. Abu Bakr is new, so maybe we do this. Next week you do first, I mean, for next 2 weeks, Abu, you do week 1 next week, week 2 week after that. But after that, for a couple of weeks, you need to do 2 homeworks per week. So you can actually match the class.
Okay, can you put that in writing and send it to me in email?
Yes. On Saturday,
so
as soon as everything is, I make sure that I have both of you. I will send an email with the details of the deadlines and what I want you to do.
Thank
I
you
will
so much.
CC, and I will CC both TAs as well, in case they get confused and they start, because we have a penalty for late submission. In case they get confused, you don't go through the penalty.
Okay, thank you. So we're gonna start submitting from week 5, right?
Yeah.
Okay, thank you. Thank you so much, Professor.
One last thing. Is there any team homeworks also, or all homeworks are individual?
No, this class is all individual.
Yeah, that's good then. Yeah.
Yeah. You didn't lose anything.
Thank you so much, Professor. Thank you.
Sure, guys. Have
Thank
a
you so
great
much,
evening.
Professor.
See you next week.
Have a great.
Bye. Take care. Bye.
Thank you.
Bye.
Professor, I do speak French.
Oh, great.
Yeah.
I guess my dad needs to talk to you.
Yeah, I was listening to that study. It was great. It was nice. Okay,
my advisor at the time actually helped a lot, because he needed to have some motivation that is useful. And then she was patient. Like I easily 10-15 minutes per day. She was discussing over colors, believe me, line colors with my father. And then when I thanked her, she said that her father was in the same situation. So she totally understands what's going on.
That was a great thing.
Yeah, that's, when you see nice people around you, remember that how lucky you are in life.
That's right.
Yeah.
All right. Thank you, Professor.
Okay, guys, have a great evening. Enjoy the night. Bye.